Bismillah ar-Rahman ar-Rahim. Let's look at this problem. You are in an old spy movie and have been locked into a small room. So you are in a small room. Let's see. The volume of this room is 1,000 cubic feet. You suddenly realize that a poison gas had just started entering the room. So let's see that someone put a poison gas inside the room through the ventilation duct. So you have a ventilation duct here. You are safe as long as the concentration is less than 100 milligram per meter cube. So the concentration of this poison gas has to be less than 100 milligram per meter cube. So if the ventilation airflow rate in the room, so you could assume that, let's say that the ventilation, there's another ventilation duct here. So the air is coming from here, mixing in the room, and going from the other side of the room. So the ventilation rate is, airflow rate is 100 feet cubic per minute. This is how much is leaving and being mixed inside the room and leaving the room from the duct. And the incoming gas concentration, the incoming gas is 200 milligram per meter cube. And we need to keep it below 100 milligram per meter cube, otherwise you'll have poison problem. Okay, so the problem is, how long do you have to escape? How much time I have in order for this human being to run from this room? Let's apply the equation that we have for a CSTR. This room acts like a CSTR because everything is completely mixed. Air in from the duct, air out from the outside or the outside duct, and the air is mixing inside the room in order to get like good ventilation. So if you apply the equation of the CSTR, I'll try to put the full equation and I'll try to show you how could you play with this equation. Qn Cn minus Q out minus volume, K, which is the rate of the degradation or the rate of the removal, times C out, if it is like a first order. For this process, it is not steady state, it's unsteady state because the poison is mixed inside the room and leaving from the outlet. So here, we cannot assume that dC over dt is 0. We should keep it as is. And also, the poison gas cannot be mixed. Cannot be biologically removed or oxidized, or there is no K for this. There is no reaction rate. So this is 0. So now you end up with V dC dt minus Q out, C out. I'll divide by the volume in both sides, so dC dt. And I'll take Q. Q in and Q out should be the same. Of course, you don't want to have like too much flow on one side and too much or lower flow on the other side. So I'll take the Q as a common factor and I'll divide by the volume. Cn minus C out. And I'll try also to reverse it in a way that I will make C out minus Cn. So it will be minus Q over volume. I'll call this C out is the final concentration C, and the Cn is Cn, normal Cn. So I'll just change it from C out to make it C. Just make it complete like that. And now I want to do try to do the integration, but let's just put the equation here. Okay, for this I have to take C minus Cn as Y. This is C minus Cn. So I'll take this. Oh, as y. And now I will do for this one dy over dt dc over dt minus dcn over dt, and now you'll have both. And you could assume that when he put cn in, cn is fixed. So cn is a fixed number, so it is not a variable, so this is 0. So the dy over dt is equal to the change. This is the final concentration, change with time. Okay, so dy over dt is equal dc over dt. So this is our equation that we got from the equation. So now we need to put the equation into the try to insert some equation here. So this is dc over dt, which is equal to dy over dt. So let's make it equivalent to whatever we have here. Here we have dc over dt. So we have it here. Is equal minus q over v. So we'll put this equation again. It is minus q over v, c minus cn, which is y. This is y here. And dc over dt is equal dy over dt. So I'll take this one. I want to right now do it in terms of the dy over dt. Okay, so now the integration is from y 0 to y at time t. And here minus q v, well, I have to rearrange this too. Well, hold on, let me just see it, because this is, I should take the delta, because I was thinking about dy dt. I'll take the y here, so I'll do the integration correctly, equal minus qv delta t. Now it's correct. So now I should take the integral for the y from y initial to yt and 0 to t. Delta y over y, and this one also minus qv. So delta y over y, this would give you ln, because it's 1 over y, it's ln yt over y naught equal minus q over volume, this is volume, t. Now we will take the ln, so it will be yt equal e q over volume so yt over y naught e to the power minus q over volume t. Okay, now we substitute c of minus c over n, I mean c minus cn, this one, for a y. So you will do it like that. So since c minus cn is equal to y, so you'll take the y, yt, which is going to be concentration at any time t minus cn, and y naught, which is c naught, which is initially the room has no Poisson, so this is going to be later on equal to 0, and this is equal to cn equal e minus q over volume T. This is 0 because initially the room was clean until you put the poison inside. Okay, so now this is we rearrange the equation. Now C minus Cn equal minus Cn e to the power minus Q over V times T, and then you put concentration, and then Cn minus Cn e to the power minus Q over volume, and then concentration final is equal Cn as a common factor, 1 minus E Okay, so we finish the solving for this to finding the equation for this unsteady state. Okay, so this is the equation, the final equation that we're going to be using in order to solve for this problem. Now remember, what was the final concentration? Should be 100. It should not be close to 100. Cn is 200. Well, milligram per meter cube. Cn is 200. Okay. And then you'll have open parentheses 1 minus E minus what's Q? Q, it is 100 feet cubic per minute. Okay, divided by 1,000 times T. You can see that this cancelled with this, and feet cube with feet cube, you'll end up with time. The time going to be in minutes. So now we have to divide 100 over 200. And that is 1 over 2 equal 1 minus E, and 100 with 2 of the zeros, 0.1 T minus 0.1 T, and then you'll take the 1 the other side, it will be minus 1/2 minus E minus 0.1 T. I'll take the minus with the minus. You'll end up with ln 1/2 equal minus 0.1 T. So T is equal to ln 1/2 over minus 0.1. So this would give you the time is in minutes, so it's going to give you 6.9 minutes. Again, you don't have to go through the derivation for this equation. If you didn't have this term, the derivation for the CMFR using the unsteady state is this equation. خلاص, this is it. C final is equal C initial times, open the parentheses, 1 minus E to the power minus Q over VT. Now, there is other rules, but this is one of the rules. If there is no degradation, there is no oxidation, this is the way we solve these problems.